discussion, we'll look at improvements that we can make to traditional assessments. And it's helpful to start with traditional assessments, homework and exams, because these are things we're often handed as new instructors. But we need to step back and ask ourselves, what do traditional assessments measure, and are there any problems with them? So this example is called the Montellation and Uses of Traxline, and if you want to take just a minute to read the following paragraph, it's a paragraph that might show up in a STEM textbook, but it's a little bit different. And if you just want to take a moment to read it and think about the types of assessment questions you might ask students, then we'll talk about it a little bit more. So if we think about what a traditional set of assessment questions might be that we would assign to students after reading a paragraph like this, we might ask them questions such as, what is Traxline, or where is it Montilled? We might ask something like, how is Traxline quasseled, and why is Traxline important? Sometimes all we might be interested in is recall, but what this points out is that it's possible for students to read a paragraph and recall it, but not understand it deeply. And so we need to be careful that we're not testing only recall, but also higher order thinking skills. So now we'll hear from Jenny Knight on the current state of affairs in introductory STEM courses. What are the Bloom's levels that we're actually testing?
This slide asks you to consider the percentage of higher order Bloom's level questions you might expect to find on a typical introductory biology exam. If you teach or think about physics or chemistry, you could substitute that in there as well. So in an introductory course, are there a lot of higher order Bloom's level questions being asked, or are there fewer higher order questions being asked? So there was a study done in 2008 that looked at AP Biology questions, undergraduate courses, GRE, MCAT, and first-year medical school exams. And this paper showed that the proportion of questions that were being asked on all of these assessments was actually pretty heavily towards the lower order level of the Bloom's scale. So the vast majority of questions were in the knowledge, comprehension, application level. Application can sometimes be higher order. And there were only a few percentages of questions in levels 4, 5, and 6, analysis, synthesis, and evaluation. So even though instructors often are trying to construct their courses in such a way that higher order questions are being considered by students, when they get to the point of asking questions on exams, they tend to ask lower order questions. So you can see in the undergraduate courses in particular, for introductory biology, that the vast majority of questions were lower order questions.
So if the vast majority of questions in biology, roughly 90%, only hit the lower levels of the Bloom's scale, then these are probably going to be the questions that we're handed as instructors. So now let's focus on a practical aspect of improving assessment, writing and adapting multiple choice questions to better suit our learning goals. And so now we'll hear from some educational experts on this theme.
So I'm Stephanie Chastain. I'm a physicist, and I work with instructors to help them incorporate research-based teaching strategies into their instruction. So one of the challenges in writing multiple choice questions is that it's really easy to write these low-level factual recall questions. They're just asking students to indicate that they remember or understand something. But our learning goals for students are often much higher than this. We want students to demonstrate that they can analyze or evaluate an idea or a concept. So what I will often do is to Bloomify up the level of a question. This is a really good exercise. So take a question that's at a really low factual recall based level and go shopping for verbs to change it around. So for example, if I had a question that was just at the lowest level of Bloom's, it was asking students to list the features of photosynthesis, for instance, or identify which of these features are features of photosynthesis. I could then look at my Bloom's taxonomy verbs and say, well, what's a verb that would let me go higher with this? Well, what about differentiate? Maybe I could ask them a multiple choice question that's asking them to differentiate between photosynthesis and oxidation, for example. So that would be getting up into the analyzing part of Bloom's taxonomy. So I find it really helpful to sort of scan the different verbs in Bloom's taxonomy and look for ones that help me think about my question in a new way. And that really helps me to increase the complexity of my questions.
When I write multiple choice items, I tend to focus on ones that apply knowledge to a new scenario or ones that involve data analysis. And that's usually because I'm trying to meet my learning goals of both science process skills and content at the same time. The way I go about doing that is to typically think through examples that I would have liked to have brought up in class that I didn't have time to do, and write scenarios that students can learn from in those examples, and then apply a principle that they learned in class to that example. That's how I can typically write an application-oriented question. And with data analysis types of questions, I sometimes think about my favorite data sets from a scientific paper and how might students be able to apply a principle from class, from the content of class, to interpreting that data set, as well as a process skill of analyzing information in order to get to the right answer. When I have time to write items like that, which they are time consuming, I usually am really happy with them. The other advantage to these is that when you have application or analysis questions where you could easily change the numbers, so you don't always have to use real data, you could use tweaked data or hypothetical data and acknowledge that in your question, then you can generate new questions on the same template for multiple new years of class.
So take just a moment to think, are there any data sets in your discipline that you think might be good to bring into a course for students to analyze? And just to narrow us down a little, focus on an introductory course in your discipline. So now we'll hear from Jenny Knight about different kinds of multiple choice questions.
There's another format called the multiple true-false format, and this preserves the ease of administration to large numbers of students, but it allows you to potentially get at whether the students have a mixed model of understanding. So for example, the way the multiple true-false looks is that there's a question stem, just like multiple choice, but then rather than picking the one correct answer, the students have to answer true or false to each statement. So there might be two true statements and two false statements, and the student might answer true to one of the true statements and false to the other true statement, or some combination therein. And what you then can see from those answers is that the student doesn't really fully understand the topic. They have some ideas correct and some ideas incorrect. So this is actually more equivalent to free response or short answer types of responses from students.